Alright, in this video here we're going to be talking about the inverse trigonometric functions sine inverse, cosine inverse, and tangent inverse. Now, I did a video a while back where I talked about these same inverse trig functions and a lot of the same information that I'm going to talk about here when I was talking about the trig functions in terms of the unit circle and the terminal points on the unit circle. Now I'm in the middle of doing videos about trigonometric functions in terms of right triangles and things like that. But the definitions of the inverse trig functions still hold no matter which definition you're using for your trig functions, whether you're using the unit circle definition or the right triangles or the right triangle with the angle in the standard position on the coordinate plane. There's three different definitions of trig functions. The definitions of the inverse trig functions and all the information about them apply no matter which one of the definitions you're using, no matter whether you're using radians or degrees to measure your angles. Doesn't matter. These things still hold. All right, so we'll kind of go through here just each one, just kind of a reminder. If you watch the videos that I've done before, then nothing on here will really be that new. If you haven't seen the videos I've done before, this one kind of sums up all together the inverse trig functions. Right. So the first one, sine inverse. Remember the notation for the inverse function is that -1 exponent, just like it is for any other inverse function. Is that sine with a -1 exponent? Also arcsine. Right now. The reason we call it arcsin, or that's another notation for the inverse sine function, you can use arcsin, the inverse sine function, to solve for the arc length of the arc of a circle. Remember, the arc is a section of the circumference of a circle. So if you know the angle that cuts out that arc of the circle, you can use the inverse sine function, or arcsine, to find the measure of that arc. That's why they call it arcsine, as well as sine with that -1. They both mean the same thing, the inverse sine function. Right? The domain for inverse sine is -1 to +1. The range is -π/2 to +π/2. Right? So in the video that I did originally on the inverse sine function, I drew an actual graph of the sine function and showed how to limit the domain to make it 1-to-1 so that we can have an inverse function. So if you want to see why the domain and range are what they are, go back and check out that video I did just on the inverse sine function, where I explain where we get these things from. Right? Like I said, this one's just kind of a quick review of things that I've covered previously in other videos that I've done. Right? So since the range of the inverse sine function is from -π/2 to +π/2, that means when we're trying to evaluate the inverse sine function using the unit circle, we only use the right half of the unit circle. Right? Remember, the right half of the unit circle, the negative y-axis would be like -π/2, and then the positive y-axis would be +y/2. Right? So when we're using the unit circle to evaluate inverse sine, we look at the right half of the unit circle, and we're looking for the y-coordinate of the terminal point, right? Because the definition of the sine function is it's the y-coordinate of your terminal point, right? So when we're doing the inverse sine function, they're giving us a number. That number represents the y-coordinate of a terminal point somewhere on the right half of the unit circle, right? And then the angle that gives us that terminal point would be the output of the inverse sine function. Right, so the definition of inverse sine inverse of x equals y, means that sine of y equals x. Right? Remember, inverse functions switch the inputs and outputs. Normally for the sine function, if I'm evaluating the sine function, I'm given an angle, and I have to figure out, well, if I put that angle on the unit circle, what's the y-coordinate of my terminal point? Well, like I was just saying, for the inverse sine function, they're giving me the y-coordinate of the terminal point, and I have to figure out what angle is going to give me that terminal point. All right, so that's a quick summary of the inverse sine function. Inverse cosine function, again, the notation is cosine with a -1, or arc cosine, right? Arccos. So the two different definitions, just like for the sine, same for tangent as well. So those two mean the same thing, the inverse cosine function. The domain for inverse cosine, same as sine, -1 to +1. The range for inverse cosine is different. And again, I explained on the video that I did on just the inverse cosine function, just like I talked about before for sine. I explained where we got these values and how we got the domain and range, and why these two are different from each other. Right? So for the cosine function, for the inverse cosine function, the range is from 0 to pi. Right? Which means when we're trying to evaluate the inverse cosine function using the unit circle, remember 0 is the positive x-axis, pi is the negative x-axis. Right? So that means I'm looking at from 0 to pi is the top half of the unit circle, and I'm looking for the x-coordinate of my terminal point, because the definition of the cosine function is it gives us the x-coordinate of the terminal point. Right? So normally for cosine y equals x, the y would represent the angle, and the x represents the x coordinate of my terminal point. When I'm doing the inverse cosine function, they're giving me the x, so they're giving me the x coordinate of the terminal point, and they're asking me to find the y, the angle that kind of points at that terminal point when I put it in the unit circle. All right, so notice here the ranges for these functions are given in terms of radians. You can just as easily switch those to degrees. So if you're dealing with the inverse sine function and your angle is measured in degrees, it will be from negative 90 degrees to positive 90 degrees. Right? For cosine inverse, it will be from 0 degrees to 180 degrees. Right? Those are the corresponding degree measures for these angles that are in radians here. Right? But you can easily switch those to degrees if you are dealing with degrees for your problem. Right? And then last one, the inverse tangent function. Right? Same notations, tangent with a -1 or arctan. Right? Both of those mean the inverse tangent function. The domain of inverse tangent is negative infinity to positive infinity. All real numbers there. The range is from negative pi over 2 to positive pi over 2. Notice here the range does not include the pi over 2 numbers. Whereas for these other ones, the domain and range does include those endpoint numbers. And the reason being is because if you remember the graph of the tangent function, it has vertical asymptotes at negative pi over 2 and positive pi over 2, so those points are not included. All right? So negative pi over 2 to pi over 2 says, once again, for tangent inverse, we're looking at the right half of the unit circle. Right? The negative y-axis would be negative pi over 2 around to the positive y-axis, which is positive pi over 2. Right, so we're looking at the right half of the unit circle, and we're looking for the y over the x. Right, remember, the definition of the tangent function in terms of the unit circle is I find the terminal point, and it's the y coordinate over the x coordinate. Well, when I'm evaluating tangent inverse, they're giving me a number that represents the y coordinate of the x coordinate, the y coordinate over the x coordinate, and I have to figure out, well, what angle will point at the point on the unit circle that when I put the y over the x, it gives me the number that I'm given here. Right, so that's how we evaluate the inverse tangent function. And again, the definition, tangent inverse of x equals y, means that tangent of y equals x. Right, so once again, for the inverse functions, they're giving me the output value of the original function. I'm looking for the angle. Right? Normally when I'm doing the tangent, the cosine, or the sine functions, any one of those, they're giving me the angle, and I have to find the terminal point on the unit circle and give either the x coordinate for cosine, the y coordinate for sine, or the y over the x for tangent. For the inverse functions, it's backwards. They're giving me the y over the x or the y, and I'm looking for the angle that points at that appropriate terminal point on the appropriate part of the unit circle that applies for whichever one of these inverse trig functions I'm dealing with. Right? So sine and tangent are the right half of the circle, cosine is the top half. Right, so those are the key things to remember when you're dealing with the inverse trigonometric functions. Now, like I've just been saying, like we have to use these inverse functions when we're solving for angles. So when we're solving trigonometric equations and we're trying to solve for an angle, we're going to use these inverse trig functions in order to solve for the angle. Or if we're solving a problem that involves like right triangle trigonometry and I need to solve for one of the angles of the triangle, I can use the inverse trig functions to solve for an angle of that triangle. And that has applications in a lot of real life problems, right? Anytime you have a physical situation that can be represented with a right triangle and you're trying to figure out one of the angles there, you can use one of these three inverse trig functions to solve for your angle, right? So that's what I'm going to be doing next. I'm going to do a couple examples where it's just find cosine inverse of this or find tangent inverse of that. And then I'm going to do a couple examples of actual word problems, solving triangles and solving for angles in a triangle and things like that. All right, so make sure you check out those other videos that I'm going to do where we actually apply this stuff to solve some problems and do some examples.